CIET NCERT presents audiobook Ganit Prakash, Part 2, Textbook of Mathematics for Grade 7.
Chapter number 4, page number 67. Another peak beyond the point. On the right side of the page, you are provided with a QR code, scanning which you can reach out to the additional resources to this chapter. 4.1. A quick recap of decimals. Recall that decimals are the natural extension of the Indian place value system to represent decimal fractions. 1 upon 10, 1 upon 100, 1 upon 1000 and so on, and their sums. For example, 27.53 refers to a quantity that has 2 tenths, 7 units, that is ones, 5 tenths, 3 hundredths. We have already learned how to multiply and divide fractions. In this chapter, we will learn how to perform these operations with decimals. You will find that the procedures for multiplying and dividing decimals are natural extensions of the procedures for multiplying and dividing counting numbers. Jonali and Pallavi play a game. Jonali says a fraction and Pallavi gives the equivalent decimal. Write Pallavi's answer in the blank spaces. On the right side of the page, we can find picture of Jonali and Pallavi. They are standing with a board which reflects fractions and decimals in 2 columns. Fractions read 3 upon 10 and corresponding decimal is 0.3. For other fractions, you are supposed to write down the decimals. The fractions are 4 upon 100, 67 upon 1000, 457 upon 100, 71 upon 100, 43 upon 100 and 9 upon 100. Jonali goes to the market to buy spices. She purchases 50 grams of cinnamon, 100 grams of cumin seeds, 25 grams of cardamom and 250 grams of pepper. Express each of the quantities in kilograms by writing them in terms of fractions as well as decimals. The fractions Jonali gave Pallavi have denominators 10, 100, 1000 and so on. Page number 68. Write the following fractions as a sum of fractions and also as decimals. We are provided by a tabular column which has 4 rows and 4 columns. The 4 columns are under the headings, namely fraction, expanding the numerator, sum of 1/10ths, 1/100ths and 1/1000ths. Last column reads decimals. In the first row, one example is done for you, 254 upon 1000. In the second column, the expanding of the numerator is expressed as 200 upon 1000 plus 50 upon 1000 plus 4 upon 1000, that is equal to 2 upon 10 plus 5 upon 100 plus 4 upon 1000. And the third column is represented as 0.2 plus 0.05 plus 0.004. And the last column reflects 0.254. For other fractions, in the second, third and fourth column, you need to complete all the columns provided. The fractions are 847 upon 10,000, 173 upon 100, and 23 upon 1000. Can you give a simple rule to divide any number by a number of the form 1 followed by zeros? 10, 100, 1000, etc. For example, 123 upon 10, 24 upon 100, or 678 upon 1000. Explore for a pattern in the previous problems. Here is one such rule. Let us consider the example 123 divided by 10. Step 1. Write the dividend as it is and place a decimal point at the end. 123 point. Step 2. Count the number of zeros in the divisor. 10 reflects 1 zero. Step 3. Move the decimal point from step 1 left by the same number of places as the count from step 2. Add zeros in front if needed. 12.3. Page number 69. Examples. Here we have 4 examples explained. 24 divided by 100 is equal to 0.24. 678 divided by 1000 is equal to 0.678. 12 divided by 1000 is equal to 0.012. 12,345 divided by 1000 is equal to 12.345. 4.2. Decimal multiplication. Example 1. Arshad goes to a stationery shop and purchases 5 pens. If 1 pen costs rupees 9.50, 9 rupees and 50 paisa, how much should he pay the shopkeeper? What operation must we use here? We have to multiply 9.5 by 5, which is the same as adding 9.5 5 times. That is, 9.5 into 5 is equal to 9.5 plus 9.5 plus 9.5 plus 9.5 plus 9.5 equal to 47.5. We can also directly multiply the numbers by converting them into fractions. 9.5 is 95 upon 10 and 5 is 5 upon 1 as a fraction. The cost of 5 pence is equal to 5 upon 1 into 95 upon 10. Recall that to find the product of two fractions, we multiply the numerators and multiply the denominators. 5 upon 1 into 95 upon 10 is equal to 5 into 95 divided by 1 into 10. That is equal to 475 upon 10. That is equal to 47.5. The cost of 5 pence is 47.5 rupees. Example 2. A car travels 12.5 km per liter of petrol. What is the distance covered with 7.5 liters of petrol? We have to multiply 12.5 by 7.5. The distance covered is equal to 12.5 into 7.5. That is equal to 125 upon 10 into 75 upon 10. That is equal to 125 into 75 divided by 10 into 10. That is equal to 9,375 divided by 100. That is equal to 93.75. The distance covered is 93.75 kilometers. Page number 70. Can the product of two decimals be a natural number? Can the product of a decimal and a natural number be a natural number? Example 3. The distance between Ajay's school and his home is 827 meters. He walks to school in the morning and then walks back home in the evening 6 days a week. How much does he walk in a week? Answer in kilometers. Each way between school and home, Ajay walks 827 meters, that is 0.827 kilometers. So, in a day, he walks 0.827 into 2, that is equal to 827 upon 1000 into 2. That is equal to 827 into 2 divided by 1000. That is equal to 1654 divided by 1000. That is equal to 1.654. He goes to school 6 days a week. So, in a week, he walks 1.654 into 6. That is equal to 1654 divided by 1000 into 6. That is equal to 1654 into 6 divided by 1000. That is equal to 9924 divided by 1000. That is equal to 9.924. Ajay walks 9.924 kilometers a week. Example 4. Find the area of the given rectangle. We have a figure of a rectangle having length 13.3 centimeters and breadth 5.7 centimeters. So, area of the rectangle is equal to 5.7 into 13.3. That is equal to 57 upon 10 into 133 upon 10. That is equal to 7581 upon 100. That is equal to 75.81. The area is 75.81 square centimeters. Observe the number of digits after the decimal point in the multiplier, the multiplicand, and the product. Also note the number of zeros in the denominator. We have a tabular column in which we have 4 columns, 1 for examples, other 3 under the caption number of digits after the decimal point in multiplier, multiplicand, and product. First example is 9.5 into 5 is equal to 95 into 5 upon 10. That is equal to 475 upon 10. That is equal to 47.5. Under multiplier, we have 1. Under multiplicand, it reflects 0. And under product, it reflects 1. These are the number of digits after the decimal point. For the second example, 12.5 into 7.5 is equal to 125 upon 10 into 75 upon 10, that is equal to 9375 upon 100, that is equal to 93.75. Here, number of digits after the decimal point in multiplier is reflected as 1, and it is reflecting 1 for multiplicand and reflecting 2 under the product column. Page number 71. We have 2 more examples here. 1.64 into 6, that is equal to 164 upon 100 into 6, that is equal to 984 upon 100, that is equal to 9.84. And number of digits after the decimal point in multiplier is 2, and number of digits after the decimal point in multiplicand is 0, and number of digits after the decimal point in product is 2. Another example reads 5.7 into 13.35, that is equal to 57 upon 10 into 1335 upon 100, that is equal to 57 into 1335 upon 10 into 100 is equal to 76,095 upon 1000, that is equal to 76 0.095. Here, the number of digits after the decimal point in multiplier is 1 and number of digits after the decimal point in multiplicand is 2 and number of digits after the decimal point in product is 3. Suppose we know that 596 into 248 is equal to 1,47,808. Can you immediately write down the product of 5.96 into 24.8? Observing the above examples, can you frame a rule to multiply two decimals? Multiplication of decimals is the same as the multiplication of their corresponding fractions. When multiplying fractions, we multiply the numerators and denominators respectively. The product of the numerators is equal to product of numbers with the decimal points removed. Since both the denominators are of the form 1, 10, 100, 1000 and so on, the product of the denominators is also of the form 1 followed by zeros. The number of zeros in the product is the sum of the number of zeros in the denominator. In the product, the decimal point is placed based on the total number of zeros in the denominator. So, to multiply two decimals, we can multiply the two numbers obtained by removing the decimal point and then place the decimal point appropriately as given here. To evaluate 5.96 into 24.8, 596 into 248 is equal to 1,47,808. 5.96 into 24.8 is equal to 147.808. We notice there are two decimal places in 5.96 and there's one decimal place in 24.8 and there are three decimal places in 147.808. So, 2 plus 1 is equal to 3 decimal places. Page number 72. Example 5. Let us use the given rule to find the product of 5.8 and 1.24. Let us first multiply 58 and 124. The product is 7,192. The sum of the number of digits after the decimal point in the multiplier and multiplicand is 3. So, the product is 7.192. Verify this by converting the multiplier and multiplicand into fractions. On the right side, we are explained the multiplication of 5.8 into 1.24. There is one digit after the decimal point in 5.8, two digits after decimal point in 1.24. Is the product always greater than the numbers multiplied? Recall multiplication of two fractions. Unlike counting numbers, when two fractions are multiplied, the product is not always greater than or equal to both numbers. Let us examine the case of the product of two decimals. 2.25 into 8 is equal to 18. In the above multiplication, the product 18 is greater than 2.25 and 8. But in 0.25 into 8 is equal to 2, the product 2 is greater than 0.25 but less than 8. In the case of 0.25 into 0.8 is equal to 0.2, the product 0.2 is less than both 0.25 and 0.8. When is the product of two decimals greater than both the numbers? When is it less than both the numbers? Since decimals are just representations of fractions, the relationship between the numbers multiplied and the product are similar to fractions. Here we have a tabular column in which we have three headings, namely situation, multiplication, and relationship. In situation 1, both numbers are greater than 1. Example, 3.4 into 6.5. In relationship, it reflects the product 22.1 is greater than both the numbers. In situation 2, both numbers are between 0 and 1. Example, 0.75 into 0.4. The relationship explained is the product 0.3 is less than both the numbers. In situation 3, one number is between 0 and 1 and one number is greater than 1. Example, 0.75 into 5. In relationship, we notice the product 3.75 is less than the number greater than 1 and greater than the number between 0 and 1. Page number 73. Figure it out. Question number 1. Recall that a tenth is 0.1, a hundredth is 0.01, and so on. Find the following products in tenths, hundredths, and so on. A. 6 into 4 tenths is equal to 24 tenths. B. 7 into 0.3. C. 9 into 5 hundredths. Question number 2. Find the products. A. 27.34 into 6. B. 4.23 into 3.7. C. 0.432 into 0.23. Question number 3. Tejas needs 1.65 meters of cloth for a shirt. How many meters of cloth are needed for 3 shirts? Question number 4. Meenu bought 4 notebooks and 3 erasers. The cost of each book was 15.50 rupees and each eraser was 2.75 rupees. How much did she spend in all? Question number 5. The thickness of a rupee coin is 1.45 mm. What is the total height of the cylinder formed by placing 36 rupee coins one over the other? Write the answer in centimeters. Question number 6. The price of 1 kg of oranges is 56.50 rupees. What is the price of 2.250 kg of oranges? Can we write 56.50 as 56.5 and 2.250 as 2.25 and multiply? Will we get the same product? Why? Question number 7. Dwarkanath purchases notebooks at a wholesale price of 23.60 rupees per piece and sells each notebook at 30 rupees. How much profit does he make if he sells 50 books in a week? Question number 8. Given that 18 into 12 is equal to 216, find the products. A. 18 into 1.2. B. 18 into 0.12. C. 1.8 into 1.2. D. 0.18 into 0.12. E. 0.018 into 0.012. F. 1.8 into 12. In which of the cases here is the product less than 1? Question number 9. In which of the following multiplications is the product less than 1? Can you find the answer without actually doing the multiplications? A. 7 into 0.6. B. 0.7 into 0.6. C. 0.7 into 6. D. 0.07 into 0.06. Question number 10. Multiplying the following numbers by 10, 100 and 1000 to complete the table. Page number 74. Here we are provided with a tabular column having 4 different columns the first column reflects the decimal numbers. The second, third and fourth column reflect multiplication by 10, multiplication by 100 and multiplication by 1000 respectively. The decimal numbers are 5.7, 23.02, 0.92, 0.306, 24.67, 4.3 decimal division. Example 6. Anuja has a 3.9 meter length of ribbon and she wants to cut it into 10 equal pieces. What is the length of each piece in decimal? Since there are 10 pieces, we can find the length of each piece by dividing 3.9 by 10. So, what is 3.9 divided by 10? Let's convert 3.9 into fraction. 3.9 is equal to 39 upon 10. Hence, 3.9 divided by 10 is the same as dividing 39 upon 10 by 10. Recall that dividing a fraction by a divisor is the same as multiplying the fraction by the reciprocal of the divisor. The reciprocal of 10 is 1 upon 10. So, 39 upon 10 divided by 10 is equal to 39 upon 10 into 1 upon 10. That is equal to 39 upon 100. That is equal to 0.39. Thus, the length of each piece of ribbon is 0.39 meters. On the right side of the page, we can find picture of Anuja with a ribbon and a pair of scissors. The length of the ribbon is 3.5 meters and she is trying to cut it into 10 pieces. She wonders, what is the length of each piece in decimal? What is the length of each piece if the ribbon is cut into 100 equal pieces? 3.9 divided by 100 is equal to 39 upon 10 into 1 upon 100 is equal to 39 upon 1000, that is equal to 0.039. When the ribbon is cut into 100 equal pieces, the length of each piece is 0.039 meters. Page number 75. What is 0.039 meters in centimeters and millimeters? By observing at these divisions, we can frame a simple rule for dividing decimals by 1, 10, 100, 1000 and so on. When we divide a decimal by 1, 10, 100, 1000 and so on, we can just move the decimal point to the left by as many places as there are zeros in the divisor. Here we have a tabular column with 5 columns and 6 rows. The first column reflects decimal and other columns reflect division by 10, division by 100, division by 1000, division by 10,000 respectively. First example is done for you, 18.7. When divided by 10 reflects 1.87. When divided by 100 reflects 0.187. When divided by 1000 reflects 0.0187. And when divided by 10,000 it reflects 0.00187. You are required to complete the other blanks with the numbers provided as 21.1 and 0.13. We also have 2 more entries given here under 100 and 10,000 as 2.146 and 0.0058. You need to fill up the blank spaces provided here. Example 7. Neenu has 29 meters of red ribbon and wants to share it equally with Anu. What is the length of ribbon that each of them will get? Since the ribbon needs to be divided into 2 equal parts, each girl will get a piece of 29 divided by 2 meters. If each of them gets 14 meters, then 1 meter remains. If we divide 1 meter among the two, each will get another 1 upon 2 meter. We can find picture of Ninu and Anu standing with the ribbon pieces, and they have a ribbon of 29 meters which has been divided into 14 plus 14 and 1 meter respectively. How do we convert 1 upon 2 into a decimal? It is easy to express a fraction as a decimal if the denominator is 1, 10, 100, 1000, etc. So, can we find a fraction equivalent to 1 upon 2 with such a denominator? 1 upon 2 is equal to 1 into 5 divided by 2 into 5. That is equal to 5 upon 10. Multiplying the numerator and denominator by 5. Page number 76. We know that the fraction 5 upon 10 can be represented as a decimal 0.5. So, each girl will get 14 meters and an additional 0.5 meters of ribbon. Hence, the length of ribbon each will get is 14 plus 0.5, that is equal to 14.5 meters. Now, what if the ribbon was shared between 4 friends instead of 2? So, each will get 29 divided by 4 meters, that is 29 divided by 4 meters. Now, the denominator of the fraction is 4. To convert a fraction to a decimal, it helps if the denominator is of the form 1, 10, 100, 1000 and so on. Can we find a fraction equivalent to 29 upon 4 with such a denominator? Is 4 a factor of 10? No. Is it a factor of 100? Yes. 4 multiplied by 25 is equal to 100. So, we can get an equivalent fraction of 29 upon 4 by multiplying the numerator and denominator by 25. 29 into 25 divided by 4 into 25 is equal to 725 upon 100, that is equal to 7.25. So, each of the 4 friends will get 7.25 meters of ribbon. Division using place value. We have learned how to divide two counting numbers to get a decimal quotient. We first represented the division as a fraction. Then we found an equivalent fraction with the denominator being of the form 1, 10, 100, 1000 and so on. It was then easy to represent this equivalent fraction as a decimal. Now let us explore the division using place value procedure to calculate the decimal quotient. Suppose we want to write the quotient 10 upon 3 as a decimal. Can we convert this fraction to an equivalent fraction with a denominator such as 1, 10, 100, 1000, etc.? It is not possible. So, we need a more general method to divide any two counting numbers. Let us find how we can use division using place value for this. Let us start with a quick recap of division using place value. Page number 77. Example 8. Find the value of 1324 divided by 4. 1324 divided by 4 is equal to divide 1324 into 4 equal parts. 1000 plus 3 hundreds plus 2 tens plus 4 ones. This can be expressed in blanks provided below this number. We have 4 different blanks to express the place values. 1000 divided by 4, not possible without regrouping. Regroup 1000 into 10 hundreds. 10 hundreds plus 3 hundreds is equal to 13 hundreds. 13 hundreds plus 2 tens plus 4 ones. This again can be expressed into 4 different blank spaces provided with the place values. 13 hundreds divided by 4. Each part gets 3 hundreds and 100 remains. 13 hundreds plus 2 tens plus 4 ones is expressed as 3 hundreds, 3 hundreds, 3 hundreds, 3 hundreds and 100. The process of division has been explained here. When 4 divides 1324, we have 0 thousands plus 3 hundreds because 13 hundreds we have, from which 12 hundreds can be subtracted. So we are left with 124. So you need to fill up the blank spaces for tens and ones. Regroup 100 into 10 tens. 10 tens plus 2 tens is equal to 12 tens. Page number 78. 12 tens divided by 4, each part gets 3 tens. 12 tens plus 4 ones can be expressed as 3 hundreds, 3 tens, 3 hundreds, 3 tens, 300, 3 tens, 3 hundreds, 3 tens. And the process of division has been explained on the right side. When 4 divides 1324, we get 0 thousands, 3 hundreds, 3 tens plus dash ones. You need to fill up the place there. 4 ones divided by 4 means each part gets 1 ones. So 4 ones can be expressed as 3 hundreds, 3 tens, 1 ones, 3 hundreds, 3 tens, 1 ones, 3 hundreds, 3 tens, 1 ones, 3 hundreds, 3 tens and 1 ones. The process of division has been explained on the right side of the page. When 4 divides 1324, we get 0 thousands plus 3 hundreds plus 3 tens plus 1 ones. So 1324 divided by 4 is equal to 0 thousands plus 3 hundreds plus 3 tens plus 1 ones, that is equal to 331. We also call this division using place value as long division. Division with a decimal quotient. Now let us use this understanding of long division to find the value of 1325 divided by 4. 1325 divided by 4 is expressed as divide 1324 into 4 equal parts. We can follow the same steps as in the previous problem. Page number 79. 5 ones can be expressed as 3 hundreds, 3 tens, 1 ones, 3 hundreds, 3 tens, 1 ones, 3 hundreds, 3 tens, 1 ones, and 3 hundreds, 3 tens, 1 ones, and 1 ones. The process of division has been explained on the right side of the page. When 4 divides 1325, we get 0 thousands, 3 hundreds, 3 tens, and 1 ones. We are left with 1 ones. It is not clear how to divide 1 ones into 4 equal parts, but we can regroup this as 10 tenths. 10 tenths can be written as 3 hundreds, 3 tens, 1 ones, 3 hundreds, 3 tens, 1 ones, 3 hundreds, 3 tens, 1 ones, 3 hundreds, 1 ones. 10 tenths divided by 4 is expressed as each part gets 2 tenths and 2 tenths remain. So 10 tenths can be grouped as 3 hundredths, 3 tenths, 1 ones as 2 tenths. 3 hundredths, 3 tenths, 1 ones and 2 tenths. 3 hundredths, 3 tenths, 3 ones and 2 tenths. 3 hundredths, 3 tenths, 1 ones and 2 tenths and 2 tenths as well. Here the process of division has been explained. Here on the right side, when 4 divides 1325, we get 0 thousandths plus 3 hundredths plus 3 tenths plus 1 ones plus 2 tenths. The tenths, ones and tenths position are explained in the division process. Page number 80. We are left with 2 tenths. To divide 2 tenths into 4 equal parts, we have to regroup them as 20 hundredths. 20 hundredths can be expressed as 3 hundredths, 3 tenths, 1 ones and 2 tenths. 3 hundredths, 3 tenths, 1 ones, 2 tenths. 3 hundredths, 3 tenths, 1 ones, 2 tenths. 3 hundredths, 3 tenths, 1 ones and 2 tenths. 20 hundredths divided by 4 is same as each part gets 5 hundredths. So 20 hundredths can be distributed as 3 hundredths, 3 tenths, 1 ones, 2 tenths and 5 hundredths. 3 hundredths, 3 tenths, 1 ones, 2 tenths, 5 hundredths. 3 hundredths, 3 tenths, 1 ones, 2 tenths and 5 hundredths. 3 hundredths, 3 tenths, 1 ones, 2 tenths, 5 hundredths and 2 tenths. The process of division has been explained on the right side of the page. When 1325 is divided by 4, we get 0 thousandths plus 3 hundredths plus 3 tenths plus 1 ones plus 2 tenths plus 5 hundredths. The places of tenths, ones, tenths and hundredths has been represented in the division process. So, 1325 when divided by 4 is equal to 0 thousandths plus 3 hundredths plus 3 tenths plus 1 ones plus 2 tenths plus 5 hundredths. This we know is 331.25. Thus, 1325 divided by 4 is equal to 331.25. Can we verify this by finding an equivalent fraction for 1325 divided by 4? To get an equivalent fraction such that the denominator is of the form 1, 10, 100, 1000 and so on, we can multiply the numerator and denominator by 25. 1325 into 25 upon 4 into 25. That is equal to 33,125 upon 100. That is equal to 331.25. Page number 81. Thus, the procedure of division using place value can be extended to find quotients with decimal values. Ones can be regrouped as tenths, tenths can be regrouped as hundredths, and so on. Example 9. Find the value of 237 divided by 8. 237 divided by 8 is same as dividing 2 hundredths plus 3 tenths plus 7 ones into 8 equal parts. To divide 200 into 8 equal parts, we need to regroup them as 20 tens. 20 tens plus 3 tens is equal to 23 tens. 23 tens plus 8 is same as 2 tens plus 7 tens remain. 7 tens can be regrouped as 70 ones. 70 ones plus 7 ones is equal to 77 ones. 77 ones divided by 8 means 9 ones and 5 ones remain. The process has been explained on the right side of the page. When 8 divides 237, we get 0 hundreds, 2 tens and remainder is 7. And when 8 divides 237, we get 0 hundreds, 2 tens, 9 ones and we have positions of tens and ones explained in the division process. To divide 5 ones into 8 equal parts, we need to regroup them as 50 tens. When we regroup ones into tens, we place a decimal point in the quotient. 50 tens divided by 8 is same as 6 tens plus 2 tens remain. The process of division is explained here. 237 divided by 8 gives us 0 hundreds, 2 tens, 9 ones and 6 tens. The values of tens, ones and tenths has been reflected in the division process. A girl wonders, says, remember, when we regroup ones into tens, we need to place a decimal point in the quotient. 2 tenths cannot be divided into 8 equal parts. So, we need to regroup them as 20 hundreds. 20 hundreds divided by 8 is same as 2 hundreds and 4 hundredths remain. The process of division has been explained here. When 237 is divided by 8, we get 0 hundreds, 2 tens, 9 ones, 6 tenths and 2 hundredths. The position of tens, ones, tenths and hundredths in the division process has been reflected here. Page number 82. To divide 4 hundredths into 8 equal parts, we need to regroup them as 40 thousandths. 40 thousandths divided by 8 is equal to 5 thousandths. The process of division has been explained here. When 237 is divided by 8, we get 0 hundred, 2 tens, 9 ones, decimal, 6 tenths, 2 hundredths and 5 thousandths. And the values are expressed in the division process for tens, ones, tenths, hundredths and thousandths. Thus, 237 divided by 8 is equal to 29.625. Division with a decimal dividend. Example 10. A shopkeeper has 9.5 kg of sugar and he wants to pack it equally in 4 bags. What is the weight of each bag of sugar? To find the weight of each bag, we need to divide 9.5 by 4. The process of division has been explained here. 9.5 when divided by 4 gives 2 ones, 0.3 tenths, 7 hundredths and 5 thousandths. In the division process, the values at ones, tenths, hundreds and thousandths place is reflected in the process. Again, we place the decimal point in the quotient Before we divide the tenths, each bag of sugar weighs 2.375 kgs. Page number 83. Example 11. What is the value of 0.06 divided by 5? 0.06 can be expressed as 0 ones plus 0 tenths plus 6 hundredths. 6 ones divided by 5 is same as 0 ones. When we move from ones to tenths, we need to place the decimal point in the quotient. 0 tenths divided by 5 is same as 0 tenths. So 6 hundredths divided by 5 is 1 hundredths and 100 remains. We need to regroup 1 hundredth into 10 thousandths. 10 thousandths divided by 5 is same as 2 thousandths. So the quotient is 0.012. The process of division has been explained on the right side of the page. 0.06 divided by 5 gives us 0 ones, 0.0 tenths, 1 hundredths and 2 thousandths. And the values at ones, tenths, hundreds and thousandths place is reflected in the division process. Figure it out. Question number 1. Find the quotient by converting the denominator into 1, 10, 100 or 1000 and verify the solution by the long division method, division by place value. A. 18 upon 5. B. 415 divided by 4. C. 1217 divided by 2. D. 4827 divided by 8. Question number 2. Choose the correct answer. A. 1526 upon 4 is equal to first 38.15, second 380.15, third 381.5, fourth 381.05. B. 3567 divided by 8 is equal to first 4458.75, second 44.5875, third 445.875, fourth 4458.75. Question number 3. What is the quotient? A. 132 divided by 4 is equal to dash. B. 13.2 divided by 4 is equal to dash. C. 1.32 divided by 4 is equal to dash. D. 0.132 divided by 4 is equal to dash. Question number 4. What is the quotient? A. 126 divided by 8 is equal to dash. B. 12.6 divided by 8 is equal to dash. C. 1.26 divided by 8 is equal to dash. D. 0.126 divided by 8 is equal to dash. E. 0.0126 divided by 8 is equal to dash. There is an image of a girl who says, remember, when we regroup ones into tenths, we need to place a decimal point in the quotient. Page number 84. Division with a decimal divisor. Example 12. Ravi went from Pune to Mathiran by scooter in 2.5 hours. The distance was 126 kilometers. What was his average speed? We can get the average speed by dividing the distance by the time taken. 126 divided by 2.5. When the divisor is a decimal, we convert the divisor into a fraction. 126 divided by 25 upon 10 is equal to 126 into 10 upon 25. That is equal to 1260 divided by 25. With the long division procedure, we find the quotient is 50.4. So, the average speed at which Ravi travelled was 50.4 kilometers per hour. Example 13. Find 4.68 divided by 1.3. Again, converting the divisor into a fraction, we get 4.68 divided by 13 upon 10 is equal to 4.68 into 10 upon 13. That is equal to 46.8 divided by 13. Now, what about 4.68 divided by 0.13? 4.68 divided by 0.13 is equal to 4.68 divided by 13 upon 100. That is equal to 4.68 into 100 upon 13. That is equal to 468 upon 13. What do you notice in these cases? When the divisor is a decimal, we can convert it into a counting number by suitably multiplying it by 10, 100, 1000 and so on. We must also multiply the dividend by the same number. Thus, 4.68 divided by 0.13 is equal to 4.68 into 100 divided by 0.13 into 100 is equal to 468 upon 13. Once we convert the divisor into a counting number, we can then follow the division using place value procedure to find the quotient. Does this ever end? Can you calculate 10 divided by 3? Try dividing using long division. 10 is 1 tens plus 0 ones. Step 1. Regroup 1 tens into 10 ones. 10 ones divided by 3 gives 3 ones and 1 ones remain. Step 2. Regroup 1 ones as 10 tens. 10 tens divided by 3 is 3 tens and 1 tenths remain. Page number 85. Step 3. Regroup 1 tenths as 10 hundredths. 10 hundredths divided by 3 gives 3 hundredths and 1 thousandths remain. Step 4. Regroup 1 hundredths as 10 thousandths. 10 thousandths divided by 3 is 3 thousandths and 1 thousandths remain. Regroup 1 thousandths as 10 thousandths. This never seems to end. Each time we divide by 3, there is a remainder of 1. Will this process end? In long division, we find that at each step we get a remainder of 1. So, the process will never end. So, 10 divided by 3 cannot be expressed using a finite number of digits in the decimal form. 10 divided by 3 is equal to 3.333 and so on. There are decimal divisions where the quotient never ends. We will explore such numbers in greater detail in a later class. Here, the process of division has been expressed on the right side of the page. When 3 divides 10, we get 3.333 and so on. Can you find the quotients of 10 divided by 9 and 100 divided by 11? Now divide 1 by 7. Will this end? Note that all the remainders we get, it starts with 1, then 3, then 2, then 6 and so on. Let us represent this as a chain. 1, 3, 2, 6, 4, 5. 1, 3, 2, 6, 4, 5. And the process repeats. 132,645. The process of division has been represented here on the right side of the page. When 7 divides 1, we get 0.142857142857 and so on. What do you observe? Can you explain why this division never ends? Not only do the remainders repeat in a cycle, the digits of the quotient may repeat in a cycle. 0.142857, 142857, 14 and so on. A magic number 142857. Let us consider the number 142857 that arose when dividing 1 by 7. Multiply 142857 by numbers from 1 to 6. Page number 86. What are the products? What do you notice? You get the same number back, but with the digits cycled around. Multiply 142857 by 7. What do you observe? Are there other such numbers? Yes. To find one such number, you can find 1 divided by 17 in decimal and use the repeating block of digits. Are there infinitely many such cyclic numbers? That is, can we keep finding more cyclic numbers or do they eventually stop? In 1927, the Austrian mathematician Emil Artin conjectured, guessed that there must be infinitely many such numbers. However, even today, nearly a century later, this conjecture remains unsolved, despite a lot of research on the question by many mathematicians. Dividend, divisor, and quotient. When we divide two counting numbers, the quotient is always less than the dividend. For example, 128 divided by 4 is equal to 32, and 32, that is quotient, is less than 128 dividend. But what happens when we divide 128 by 0.4? 128 divided by 0.4 is equal to 320. The quotient is greater than the dividend. Will the quotient be always greater than the dividend when the divisor is a decimal? Try it out with different values of the divisor. Describe the relationship between the dividend, divisor, and the quotient. Create a table for capturing this relationship in different situations, like we did for multiplication. Figure it out. Question number 1. Express the following fractions in decimal form. A. 2 upon 5. B. 13 upon 4. C. 4 upon 50. D. 5 upon 8. Question number 2. Find the quotients. A. 24.86 divided by 1.2. B. 5.728 divided by 1.52. Page number 87. Question number 3. Evaluate the following using the information. 156 into 12 is equal to 1872. A. 15.6 into 1.2 is equal to dash. B. 187.2 divided by 1.2 is equal to dash. C. 18.72 divided by 15.6 is equal to dash. D. 0.156 into 0.12 is equal to dash. Question number 4. Evaluate the following. A. 25 divided by dash is equal to 0.025. B. 25 divided by dash is equal to 250. C. 25 divided by dash is equal to 2.5. D. 25 divided by 10 is equal to 25 into dash. E. 25 divided by 0.10 is equal to 25 into dash. F. 25 divided by 0.01 is equal to 25 into dash. Question number 5. Find the quotient. A. 2.46 divided by 1.5 is equal to dash. B. 2.46 divided by 0.15 is equal to dash. C. 2.46 divided by 0.015 is equal to dash. Is the quotient obtained in 24.6 divided by 1.5 the same as the quotient obtained in 2.46 divided by 0.15? Question number 6. A 4-meter long wooden block has to be cut into 5 pieces of equal length. What is the length of each piece? Question number 7. If the perimeter of a regular polygon with 12 sides is 208.8 centimeters, what is the length of its side? Question number 8. 3 liters of watermelon juice is shared among 8 friends equally. How much watermelon juice will each get? Express the quantity of juice in millimeters. Question number 9. A car covers 234.45 kilometers using 12.6 liters of petrol. What is the distance travelled per liter? Question number 10. 13.5 kg of flour, that is atta, was distributed equally among 15 students. How much flour did each student receive? Here we have a tabular column in which we have fractions and their corresponding decimal value. 1 upon 2 is equal to 0.5. 1 upon 2 into 2 is equal to 0.25. 1 upon 2 into 2 into 2 is equal to 0.125. 1 upon 2 into 2 into 2 into 2 is equal to 0.0625. 1 upon 2 into 2 into 2 into 2 into 2 is equal to dash. You need to write down the value here. 1.5 is equal to 0.2. 1 upon 5 into 5 is equal to 0.04. 1 upon 5 into 5 into 5 is equal to 0.008. 1 upon 5 into 5 into 5 into 5 is equal to 0.0016. And 1 upon 5 into 5 into 5 into 5 into 5 is equal to dash. You are supposed to fill up this blank space. What pattern do you observe? Why are 2 and 5 related in this way? Page number 88. 4.4. Look before you leap. Did you know that it takes the Earth 365.2422 days to go around the Sun and not 365 days? For our convenience, we consider 365 days as a year in a calendar. We are talking about Gregorian calendar. This means that after one calendar year or 365 days, the Earth still needs 0.2422 more days to complete one full revolution around the Sun. This doesn't seem like much, but what happens after 100 such calendar years? Using our understanding of decimal multiplication, 0.2422 into 100 is equal to 24.22 days. After 100 calendar years, the Earth will need 24.22 more days to complete its 100th revolution around the Sun. In your science classes, you have learnt that we experience seasons because of the Earth's tilt in axis and its revolution around the Sun. If our calendar does not accurately indicate the position of the Earth around the Sun, our seasons and our annual calendar will not match. To correct this problem, the idea of a leap year was introduced. Every fourth year, one additional day is added to the calendar year. On this page, there is a cartoon displaying date 31 December and the icon says, "Hey, I have not yet finished." Making an adjustment. Here we find people sitting and discussing about making an adjustment like add an extra day every 4 years. Page number 89. Is the year divisible by 4? If yes, the year has 366 days. If no, the year has 365 days. Do you know which month has this extra day? Let us find how this solution works. There is a table column provided here for 8 years and the corresponding number of days. Year 1, 2, 3 have 365 days. Year 4 has 366 days. Year 5, 6 and 7 have 365 days and year 8 has 366 days. Observing the above sequence, the number of days after 4 calendar years is 4 into 365 plus 1, that is equal to 1461 days. What is the number of days that the earth needs to make 4 full revolutions around the sun? 4 into 365.2422 is equal to 1460.9688 days. With this new scheme of adding one extra day every fourth year, what is the number of days in 100 calendar years? Can you write an expression to calculate that number? Here is one way to form the expression. Each calendar year has 365 days. In 100 calendar years, the number of days is 100 into 365. But years that are divisible by 4 have one extra day. How many years are divisible by 4 in 100 years? So, the number of days in 100 calendar years is 100 into 365 plus 100 divided by 4 into 1, that is equal to 36,525 days. Can you form different expressions for the same question? The actual number of days that the earth takes to go around the sun 100 times is 100 into 365.2422 is equal to 36,524.22 days. Thus, by adding a day every fourth year after 100 years, the calendar days are more than the actual number of days taken by the earth to go around the sun. We have overcompensated. Page number 90. So, the good people who designed calendars decided that they will not add one extra day in every 100th year. Making another adjustment. Here there is a picture in which we find people sitting and deciding that no extra day in the 100th year. Is the year divisible by 100? If yes, the year has 365 days. If no, is the year divisible by 4? If yes, the year has 366 days. If no, the year has 365 days. Can you write an expression for the number of days in 100 calendar years with this new adjustment? We saw that there are 25 years divisible by 4 in 100 years. 100 is also divisible by 4, but we have to exclude it. So, only 24 years have 366 days and the rest 76 years have 365 days. So the expression can be written as 100 by 4 minus 100 upon 100 within brackets into 366 plus 100 minus within brackets 100 upon 4 minus 100 upon 100 into 365, that is equal to 24 into 366 plus 76 into 365, that is equal to 36,524 days. This is close to 36,524.22 days, but is it close enough? What happens after 1000 years with this adjustment? Page number 91. If we follow this new scheme of adding one day every 4 years, but not in the 100th year, the number of calendar days in 1000 years is 36,524 into 10, that is equal to 3,65,240 days. The number of days the earth takes to go around the sun 1000 times is 1000 into 365.2422, that is equal to 3,65,242.2 days. So, there is a difference of 2.2 days. To bridge this gap, it was decided that every 400th year would be a leap year. Here we find another picture in which people are sitting and they decide to add an extra day every 400th year. Is the year divisible by 400? If yes, the year has 366 days. If no, is the year divisible by 100? If yes, the year has 365 days. If no, is the year divisible by 4? If yes, the year has 366 days. If no, the year has 365 days. With this scheme, let us calculate the number of days in 1000 calendar years. Page number 92. In 1000 calendar years, how many years are divisible by 400? 2. In 1000 calendar years, how many years are divisible by 100 but not divisible by 400? 10 minus 2, that is equal to 8. In 1000 calendar years, how many years are divisible by 4 but not divisible by 100 and 400? 250 minus 10 is equal to 240. The rest of the years are 1000 minus within brackets 2 plus 8 plus 240, that is equal to 750. So, the total number of days in 1000 calendar years is 750 into 365 within brackets plus 240 into 366 within brackets plus 8 into 365 in brackets plus 2 into 366 within brackets is equal to 3,65,242 days. The earth needs 3,65,242.2 days to go around the sun 1000 times. Hence, in 1000 years, the calendar year is slightly shorter by 0.2 days than the actual number of days the earth takes to go around the sun. The calendar makers did not want to bother about a small difference that would happen in 1000 years. So, they left the scheme of leap years as is. Making yet another adjustment. Here we find another picture of people sitting and trying to make another adjustment. With this final scheme of leap years, can you calculate the number of calendar days in 10,000 years? and the number of actual days the Earth will take to make 10,000 revolutions around the Sun? What is the difference? If there is a big difference, can you suggest a way to fix this problem? Page number 93. Do you wonder how people figured out that the Earth completes one revolution around the Sun in exactly 364.2422 days? Investigate how traditional calendars in India manage to consistently align the days in the calendar with astronomical events like the Earth going round the Sun or even the positions of the stars in the sky accurately. Figure it out. Question number 1. A 210-gram packet of peanut chicky cost 70 rupees 50 paisa, while a 110-gram packet of potato chips cost 33 rupees 25 paisa. Which is cheaper? Question number 2. Write the decimal number at the arrow mark provided in the picture. We have a number line which reflects 3.1 and 3.2 with 10 equal divisions, and there's an arrow at the 6th position. In the next picture, we have again 10 divisions between 2.15 and 2.17, and there's an arrow pointing at the 6th position. Question number 3. Shyamala bought 3 kg bananas at 30 rupees per kg. She counted 35 bananas in all. She sells each banana for 5 rupees. How much profit does she make selling all the bananas? In the picture, we can find Shyamala having bananas which she is selling here at 5 rupees per banana rate. Question number 4. A teacher placed textbooks that are 2.5 centimeters thick on a bookshelf. The teacher wanted to place 80 textbooks on the shelf. The bookshelf is 160 centimeters long. How many books could be placed on the shelf? Was there any space left? If yes, how much? Page number 94. Question number 5. Fill in the following blanks appropriately. 1 centimeter is equal to 10 millimeters. 1 meter is equal to 100 centimeters. 1 kilometer is equal to 1000 meters. 1 kg is equal to 1000 grams. 1 gram is equal to 1000 milligram. And 1 liter is equal to 1000 milliliters. 5.5 kilometers is equal to dash meters. 35 centimeters is equal to dash meter. 14.5 centimeters is equal to dash millimeter. 68 grams is equal to dash kg. 9.02 meters is equal to dash millimeters. 125.5 milliliters is equal to dash liters. We are expected to fill up the blanks here which have been provided against the decimal values. Question number 6. The following problem was set by Sridharacharya in his book Patiganita. 6 1 upon 4 is divided by 2 1 upon 2 and 61 upon 4 is divided by 3 whole 1 upon 2. Tell the quotients separately. Can you try to solve it by converting the fractions into decimals? Question number 7. Fill the boxes in at least 2 different ways. A. One box, multiplication sign, another box is equal to 2.4. B. There is a box with multiplication sign, another box that is equal to 14.5. Question number 8. Find the following quotients given that 756 divided by 36 is equal to 21. A. 75.6 divided by 3.6. B. 7.56 divided by 0.36. C. 756 divided by 0.36. D. 75.6 divided by 360. E. 7560 divided by 3.6. F. 7.56 divided by 0.36. Question number 9. Find the missing cells if each cell represents A divided by B. Here we have a tabular column provided in which we have 6 columns and 6 rows. A reads 1517, 151.7, 15.17, 1.517 and 15,170. In column 1, we have the values as 37, 3.7, 0.37, 0.037 and 370. These values in the first column are representing B. The first division is given as an example. When you divide A by B, that is 1517 by 37, we get 41. Likewise, another division is also explained here. 15.17 when divided by 3.7 gives us 4.1. Another example is 151.7 divided by 0.037, we get 4100. And rest all blank spaces you are expected to calculate and fill up in the tabular column. Question number 10. Using the digits 2, 4, 5, 8 and 0, fill the boxes to get the A. Maximum product, B. Minimum product. We have 2 boxes, decimal, another box, into 1 box, decimal, another box. We are expected to write down the digits provided and manage to get the maximum and minimum product as asked in A and B part. Page number 95. C. Product greater than 150. D. Product nearest to 100. E. Product nearest to 5. Question number 11. Sort the following expressions in increasing order. A. 245.05 into 0.942368. B. 245.05 into 7.9682. C. 245.05 divided by 7.9682. D. 245.05 divided by 0.942368. E. 245.05. F. 7.9682. Summary. In this chapter, we learnt procedures to perform decimal multiplication and division. For decimal multiplication, we first multiply the multiplier and multiplicand as counting numbers. The number of decimal digits in the product is the total number of decimal digits in the multiplier and multiplicand. Division of decimals uses the same procedure, that is, division using place value, long division, as with counting numbers. The regrouping continues after the ones placed to tens, hundreds, thousands, and so on. When the ones are regrouped to tens, a decimal point is placed in the quotient. There are decimal divisions where the quotient never ends. After each regrouping and dividing, there is always a remainder. Then on this page comes the puzzle time. Hidato. We have puzzle explained here. On one side we have the puzzle given. On the right side we have the solution. Page number 96. In Hidato, a grid of cells is given. It is usually square shaped like Sudoku or Kekoro, but it can also indicate hexagons or any shape that forms a tessellation. It can have inner holes like a disc, but it is made of only one piece. Usually, in every Hirato puzzle, the lowest and the highest numbers are given on the grid. Your task is to fill the grid such that there is a continuous path of consecutive numbers from the lowest to the highest number. The next number must be in any one of the adjacent cells, including diagonally adjacent cells. The grid comes pre-filled with some numbers with values between the smallest and the highest to ensure that these puzzles have a single solution. Try solving the following Hirato puzzles. We have been provided with 3 more puzzles here to try with, and there is also a picture of some kids wondering to solve these puzzles. Chapter 4 ends here.
Ganit Prakash, Part 2. You were just listening to this audiobook, Textbook of Mathematics for Grade 7. Narration, Swarnlata Sharma. Sound recordist, Prasoon Kumar. Assistance in production, Amarjeet Sarkar. Directed and produced by Vimlesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.